All right, everyone, please type yes in the chat if you're able to hear me. All right, perfect. We'll get started then. So, welcome everyone to this Arduino workshop for the fall 2020 semester. My name is Kevin George, the current president of IEEE, and I will be hosting this workshop for today. So, let's get started. So, what is Arduino? Simply put, Arduino is an open source physical computing device that integrates I/O, power, and an development environment all in one package. As you can see here, this is an example of an Arduino microcontroller device. This is one of the form factors that the microcontroller sits on. There are different variations of the Arduino with different connectors, different capabilities, different components, etc. But it all is based on a single microcontrolling platform. Over here, we have another example of the Arduino platform, but sitting on a different device. This one has a micro USB connector. It's got Wi-Fi capability and has fewer I/O, but is in a smaller form factor. So all these models are different and they have different capabilities, but one thing in common is that they all are centered around a single microcontroller based on the Atmel Mega either 320 AP or other variations of the microcontroller. So in short, the Arduino itself is just the interface for this microcontroller. That's something that is a common misconception about Arduino. It itself is not the microcontroller, but an interface for the microcontroller, aka this device over here. So as I said, each board looks different, has different capabilities. It even comes in from different manufacturers. I know some manufacturers like to make their own variations around this open. Oh, absolutely, yes, I can make this full screen. I gotta move this percent. All right. So the Arduino can come from different manufacturers as it is an open source platform. And you can use different IDEs and languages to program this, even though the Arduino company itself has its own development environment. So for this particular workshop, we're going to be using the Arduino Uno because it's a very popular variation of the Arduino platform. It's very easy to get started with, and it's common with beginners and people who just want to get started with prototyping. For this workshop, we'll be programming using the Arduino the IDE, the one that the company has built itself, using the C language. Uh, for this particular workshop, I'll be using a simulation website to show you the circuit, the Arduino, and the code running. So it'll be easier for you to see. So if we take a look at the Arduino Uno that we'll be using today, you'll see a bunch of different things. So we'll get started section by section. So on the left-hand side, you'll see the USB Type B port, which is used for programming, updating, getting serial data, and any statuses. It simply plugs in from a USB Type B to USB Type A or USB Type C uh, into a computer, so you can easily program from the development environment and get all that serial data in and out. On the bottom of the left hand side, you get that DC barrel connector. You can use any standard DC barrel jack that as long as it supplies 7 to 12 volts of power. It can be very handy if you have high powerful components that require a little bit more extra power that the 5 volts from the USB Type B port can't provide. It also is helpful if you don't necessarily need to do any programming, but you want the microcontroller running anyway. So you can just plug in that standalone power and it'll run the program indefinitely. On the upper left-hand side, you'll get that reset button. So in case something gets stuck or you want to start from the beginning, you can just click that reset button and it reinitializes the program and runs it from the beginning. Uh, and then in the middle, you get that oscillating crystal for use as a clock for the microcontroller. On the bottom right side, you get the Atmel Mega 328 PPU microcontroller itself. So this is the brains behind the operation. This is what is actually the microcontroller, and you'll get to see and you're able to swap it out and put it back in case something burns out or you want to try a different microcontroller and so forth. It simply sits on a socketed jack. On the bottom, you get those one set of pins. So on the left hand side, you get that the power in and out. So you're able to simply run 5 volts, 3.3 volts off the board itself in case you're not able to get standard 5 volts or 3.3 volts from an external source. You also get the grounds and the inputs in case you do want to run internal power, but you don't have a barrel connector. And then the bottom right side, you get the analog input and output. So you get digital input output and you get analog input output. This is very important if you're planning to use like photoresistors or different components that are solely based off analog input and output. Uh, you can reference the analog pins in the program, and it's very useful for different components. So on the upper side of the board, you get the digital pins. So just like the analog pins on the bottom, you get the digital pins. So this simply is either a 5 volt or a 0 volt input output, as digital states. So you get up to 13 on the Arduino Uno. So it's easy for a beginner to just get started with. And then you get a built-in LED with the Arduino Uno. So instead of, if you don't want to plug in a external LED to program, you do get a built-in LED that you can play around with in program. And then towards the middle, you get a pair of LEDs there. Those are for transmission and receiving for serial data. So if you're planning on using the USB Type B port for programming, you get to see the serial input and output coming in and out. And then on the right-hand side, again, you get an ICSP port. It's useful for as serial port communications, or if you want to use some external accessories. I was using this port last week for a camera, and I'm able to power the camera as well as the Arduino off the camera itself. So the camera provides the power to the Arduino, which is actually pretty useful. So it's not a common port that a lot of people use, but it's very useful for specific accessories. So moving forward, we're going to start with our first circuit. We're have an LED run off those digital inputs and digital pins that we just talked about. And you can see how we can program hardware. So I'm just going to share, I'm going to minimize this. So for the purposes of this workshop, I'm going to be using the Tinkercad website. They're a great website for you to just get started with Arduino without actually having to purchase any type of hardware. So you can just simply get a list of behind my code. You can see you get every single component that you need to get started. It's not, you don't specifically have to use Arduino for this. You can use any other device and any other electronic device and just prototype your electronics from here. I'm looking in the chat. Robin asked can you add more ports or only 13? So as I said, with this specific model, the Arduino Uno, you do get 13 digital inputs and outputs, and you get 6 analog inputs and outputs. But there are different models that have more inputs and outputs, such as the Arduino Mega. You get a whole bunch of inputs and outputs that you can use for a lot of different things. So those are available. So going back to Tinkercad, I'm going to start by having my Arduino here on the left side. I have a breadboard here. The breadboard, we can simply socket components, and we can get started with our first circuit. So I have the 5 volts coming off the power, and I have the ground coming into the ground of our power rails. So that way we can easily just hook different components up without occupying different 5 volt lines. So I'm gonna get a resistor. I'm just gonna place it on the board. I'm going to rotate this so we're not on the same line. Um, Rotate it one more time. There, it's 90 degrees. So we have our first resistor here. And I'm just gonna simply, hold on. This is a 1K resistor. I need I'm gonna make this 220. I'm going to make it ohms, not kilo ohms. I am going to rotate this component. There. That's how it should be. I'm going to add an LED simply right here. I'm going to rotate this like this. I'm going to run 5 volts here. That's going to go to our LED. Or, hold on, my mistake. I'm going to run it to resistor. The resistor from there, I'm going to plug into pin 2 like so. So we have a wire coming from the LED to the resistor to pin 2. And then I'm going to have the other lead go to ground like this. Hopefully you can see that clearer, but this is how our wiring diagram is going to look. So then we're going to go to our code. As I said, you normally would be using the Arduino IDE platform. That software is available either from the Microsoft Store for Windows, or if you're on a Mac or Linux, you can simply download it from the Arduino website. So you can go here, go to the software, go to downloads, and everything you need is right here. So going back to our diagram, we're just going to use the built-in compiler and developer environment just to simulate our code here. So within every standard template, you're going to get 2 blocks of functions. This is a standard, so you're going to have a setup function and a looping function. So we use the setup function to declare our initial non-looping conditions like setting up what pin does what, or our variables, and so forth, you typically want to put under the setup function because those are going to initialize once and are not going to be continuous. However, in our looping function, this is where we want to have our actual program. So as I said, the Arduino runs indefinitely. So as such, it is a looping function which we actually do our programming in. So it will run indefinitely from this function here. But going back to our setup function, we're going to simply start our programming and initializing our components. So as we see in our wiring diagram, we have set up our LED to be on digital pin 2. So that's digital pin 2 right here. And since an LED is something that we visually see and manipulate, we want that to be an output. So that's something that we can control ourselves. It's not a sensor, it's an output. So we're going to simply declare the pin mode. Also keep note that it is case sensitive. So you will get compilation errors if it's not certain things and certain functions aren't capitalized properly. So definitely keep that in mind. So we're going to start declaring our pin mode for this pin 2 by using the pin mode function 2 and since we declared it as an output, we're going to simply say output and semicolon. So as I said before, this is in C. So if you're not familiar with C, definitely look into it because that is what's used with the Arduino Uno and the Arduino IDE. Um, but you can also use different languages as well, but C is the standard with Arduino. So we declared our pin mode here. We can move on to our looping function. Since this is on the digital line, we want to write and declare a value to turn on this LED. To do that, we're going to use our built-in function, digital write. This states that we are writing on that digital input and output. We're going to declare a value, so that's pin 2. We're going to do that. We're going to do a high. So you get either low or high with digital inputs. And in this case, we're going to give it a value of high. So I will start the simulation. So there we go. We see that pin 2 is writing 5 volts into our circuit because it's either 5 volts or 0 volts for high and low. And it's just simple as that. We simply turned on our LED. I don't know if you're able to see this correctly, but if I change it to maybe white, I'm not sure if you can see that better, orange. If I stop the simulation, you see the LED's off. If I start the simulation, you see the LED turns on. So that's just a basic way of getting an LED turned on. I'm gonna stop the simulation now. Getting an LED on is fun and all, but we can do a little bit more to play around with this. So I can use some other built-in functions to maybe make the LED do different things. We can use a built-in timing function, the delay function, to turn on and off the LEDs by time. Uh, it's in a certain measurement of time. So 1000 equals to 1 second. So keep that in mind when you're doing your programming. That's the units that this built-in delay function uses. So I'm just going to say I want this to wait 1 second before doing our next function. So at this point, our LED is already on. So maybe let's try to turn it off. So we're going to call our digital write function. That's pin 2. And we're going to give it a value of low since that will be our 0 volts. And I'm just going to do another delay function. And let's see what happens. So you can see in our circuit, it's turning on, waiting a second, turning off, and then waiting a second. And since it's in our looping function, it's going to keep reiterating that indefinitely. So you can see that, doing some simple programming can do a lot with hardware. Okay, let's add some more hardware. Let's try to add another LED. I'm going to rotate this again. I'll keep this red. I'm going to get another resistor. This would be 320 ohms. Rotate that again. Put this to ground. And this time, instead of pin 2, I'm going to put this in pin 3. So I put another LED on our digital pin 3. So if we go back to the code, since we have another piece of hardware, we have to declare what that hardware is and what it does. So I'm going to put pin mode 3. Once again, our built-in pin mode function. I'm going to declare the third digital pin in our code to be an output. And let's modify this piece of code so that uh, once our first LED turns off, that second LED will turn on. So we're going to call our digital write function again to be 3. And let's make that value high. I'm going to put another delay on this. And let's make it turn off after this. Low. Put one more delay function to make this work seamless. So I'm going to start our simulation and let's see what happens. So you can see our first LED turns on and off, and then our second LED turns on and off. This is exactly what we declared in our code. So we have digital write high, wait a second, then turn off, wait a second, then the second one turns on, wait a second, and then the second one turns off. Then we're going to wait a second, and then we're going to go all the way back to the beginning. Now I just want to add one more LED, and you'll see what I'm getting at. So we're going to go back to our LED. Go right here. I'm going to get a resistor. That's going to go to ground. Actually, no, my mistake. That's going to go to, we'll put that on pin 4. I'm just going to change this wire to, this will be green. I'll change this to red, this wire color to red, so you can see it more clearly. I'll change this to orange. And then I'm going to put this to ground. So I have another new piece of hardware on pin 4. So once again, I'm going to use our built-in pin mode function. So that's on pin 4 to be our output. Let's start with a new batch of code. I also want to change this LED to be green. Pin mode, that was 3. This time I'm going to do a delay function of 2 seconds. Then I'm going to do another digital write. Of 2. Too high. Then I'm also going to do, at the same time, turn off the other LED. I'm going to do another delay function. Do digital write too low. So our new piece of hardware is on pin 4, so 4 high. Away. 2 seconds. Let's see what happens after I run this code. Let me just write one more function. Let's see what happens. So you can see, I hope you can see that I pretty much made a basic traffic light. This is especially useful for those who are currently taking FED and are needing to do the traffic light project. So this is pretty much how you would go about making that circuit. So you can see the red LED turns on for 2 seconds, turns off, and the yellow one turns on, turns off, and the green LED turns on, then turns off after those 2 seconds. So take note of this. This is how you would go about that. Um, so LEDs are great, but we also want to do things with inputs. So we're going to move on to a second circuit. We're going to be using push buttons to control our circuit. And we're going to use different if-else statements to do different actions. So if we go back to our Tinkercad software, I'm going to clean everything up. I'm going to remove all these LEDs. I'm going to keep the 5 volts and the um, ground. I'm also going to clear out our code right now. So we're going to start from scratch. Push button. Going to get resistor. Actually, I'm going to move this to be in the middle of the board. We don't want those pins to be touching each other on the same line. I'm going to get a resistor. I'm going to put it here on this line. I think 1K should be enough. And then I'm going to put this to ground. Let's make it black. I'm going to hook up one pin of our switch. Let's put that into digital pin 2. Make this purple. Bring that up like that. And then I'm going to have another part of our wire button go to 5 volts. Let's make that red. I'm going to have another resistor over here. I also want to ask, does anybody have any questions so far? Is everyone able to understand what I'm saying so far? Is there any confusion? I want to make sure I'm not going too fast or too slow. So definitely give me some feedback if there's an issue. I'm going to hook up our LED. It's pin 3. Let's make this pink, I guess. Let's make this black. And let's get back into our code. So again, we're going to start from scratch. Um, so we have two pieces of hardware. We have our LED and we have our push button. This is the configuration we want to set it up as. Um, so we're going to, as we said before, we're going to use our built-in pin mode function to define these pieces of hardware. So our LED is on digital pin 3. We're going to start again with our second piece of hardware, the button. That button is on pin 2. So instead of output, since this is a input device, we're going to use the input label. So our button is our input, which is our microcontroller is going to receive data from, in a sense, and that's going to be our input. So our two pieces of hardware are defined, our input as the LED, our output as the LED, and our input as the button. So we move on to our looping function. I'm going to say, so what I want to do is if we push the button, this LED is going to turn on. So how we do that is, if you're familiar with it, we're going to use what's called an if statement. So we're going to say if our button is pressed, our LED turns on. So we can start with this. So instead of a digital write, we're going to use a digital read for our input. That's pin 2. Let's say since it's high, we're going to do a digital write 3, say high. And we're going to use our built-in delay function for, let's say, half a second. And then let's say if digital read 2 equals to low. So if our button is not being pressed down, we're going to turn our LED off. Then once again delay 500 half a second. So this is the code I'm writing. So basically put, if we press the button down, it's going to turn our LED on. If we let go of it, the LED will turn off. So let's see when we run. So you can see when I push the button, our LED turns on. Let's make it a little bit longer since you are not really able to see it. Let's make it for a second. And let's change the color to something more visible. Let's make it orange. Yeah, orange should be fine. Let's see what happens. So we run our code again. Let's see when we press the button. Our LED turns on. When we let go of the button, the LED turns off after a second. Once again, LED is on. We let go, LED turns off. So that's pretty much how you would make a circuit to turn on an LED using a button. Let's make it a little bit more complex. I'm going to add the button right in the middle here. Let's put it a little bit left. Resistor. Rotate that. All right, let's move our other resistor a little forward down. Let's put that to ground. Let's make that black. I want to put this 5 volts. Let's make this go to pin 4. Let's make this turquoise. Yeah, that should be a good color. Oh, I removed our LED. Rotate this. I want to get another LED. Oh, what happened? Oh, I might have deleted a circuit. Let's let this go into pin 5. Green should be fine. Let's go back to our code. We put 2 new pieces of hardware. We put another button, and then we put another LED. Let's make this LED a different color. Let's make it green. So we put our second button on pin 4. So once again, I go use our pin mode function. Another input. Our LEDs on pin 5. And then when we go back to our code, let's say So we're going to read the state of our second button, which is on pin 4. So if digital read 4, it's behind. We're going to fine. Let's make this 2 seconds. Slow. Five. Low. 2 seconds. Let's run this code and let's see what it does. So USB is plugged in. Uh-oh, what's going on? Let me see. This is wired correctly. It's wired correctly. It's high. Digital reach 4. That's in 4 is an input. 5 is an output. Oh, put it on the other line. Let's put it on this one. Let's try it now. There we go. So you see, I press my second button. The second LED turns on. I press my first LED. My first button, and the first LED turns on. I know it's difficult to see. It's just the software. This is not going to happen with the actual hardware. Um, you'll be able to really see it clearly, and it'll let you be able to work without that little delay. So once again, I push the button down. The green LED turns on. I push the other button. Um, our other LED turns on. So pretty much, the possibilities are endless. We can see that we can add whatever piece of hardware we want, and we can put whatever code we want, and it's going to do different things. Let me see. Let's use a different type of sensor. So I'm going to clear our board again. Oops. Oh, so let's get started with a sensor. Let's do a photoresistor. Um, Resistor. I'm going to put this right here. I need a little bit of space. Let me put it up here so you can see it better. I want that to be It's 100 ohms. Then I'm going to have that go to ground. Then I'm going to have this one go to 5 volts. Let's make this one red. Actually, let's move this one up one more. I'm just gonna have it like this. Then in between, I'm going to have this one wire, and let's have it go into analog A0. I'm gonna change this to, let's make it pink. Let's make it pink again. Then I'm going to have, let's say, resistor. That's going to be 220 ohms. So by now you should know the same procedure. Let's put it pin 2, digital pin 2. Let's keep that green. And I'm going to have this go to this black. So we'll see here, we have two pieces of hardware. We have a photoresistor and we have an LED. So in our code window's open. So we'll have pin mode. Pin mode. What was it? 2 outputs. What is that up? So instead of using pin mode for our sensor, I'm going to simply just not use that because where it's an analog pin, uh, we don't have to really define that as an input or output. So I'm going to go into our looping function. So with our analog input and output, it's a value between 0 and 1023. So you'll get, with depending on the sensor, you'll get uh, between those two, that one range. So we'll say if analog read, we're going to be using analog read instead of digital read for our analog input and output. So digital read, that was on 0. Let's say it's less than, equal to, let's say 75. Digital right. Pin 2, 2. Let's do that for a second. Let's see what happens. Oh, what happened? Okay. Okay, and this maybe change it to a less sensitive value. Also, let's put another if statement to turn it off. Let's run this. Let's see what happens. So you can see when this is of course a simulation. In real life, you would probably use either the sunlight or a finger to cover this up or to let it read in the light with our photoresistor. So you can see I'm simulating. It's currently dark right now, so our LED is going to be on. But if I slowly expose it to sunlight, our LED is going to turn off. So we can see we're reading a non-binary value from our sensor as an analog value into our analog in, and we are manipulating those set conditions to manipulate another LED. So as you can see, turn on the light, I expose the photoresistor to light, the LED turns off. I expose the photoresistor to darkness, the LED turns on. So that's pretty much it for today. Um, I showed you how to use digital inputs and outputs and with code to manipulate different pieces of hardware. And I've just shown you how to use a sensor to in combination with code to manipulate a different piece of hardware. Uh, Different sensors. There are different types of sensors. There's ultrasonic sensors. I just use a photoresistor. Different pieces of hardware such as servos and motors. The possibilities, like I said, are endless. It's a matter of understanding the hardware, the values it can take in, or the values it spits out, wiring it correctly, and programming it correctly with to do whatever you need it to do. So that pretty much concludes our demonstration part of the workshop, and that pretty much concludes our workshop as a whole. I really hope that you were able to get a little bit of information about the basics of the Arduino platform, and that you are able to get an idea of what you'd want to do as your own projects, or if you have any type of classwork or homework, how you would go about, using the Arduino platform to accomplish what you need to. And I hope that besides your homework and classroom classwork, you can use the Arduino platform for personal projects and really learn and get a handle on how it's used. So before I conclude, does anybody have any last minute questions or concerns or anything they'd just like to speak out? Okay, I don't see any questions so far or anything else. So if that's the case, if you have any questions later on or you want to get in contact, get in touch with us with Discord. If you're not already part of our IEEE Discord, uh, you know, uh, go on our website. The information's there. And I hope that you really enjoy this workshop and that you enjoy the Arduino platform. And with that, I'll conclude our workshop for today.